We're always hearing about these incredible new AI models, right? But today, we're going to pull back the curtain and look at the one thing that makes it all tick: the data.
So let's just jump right in. When you picture some super powerful AI, what do you think is its most critical ingredient? Its secret sauce. Is it the fancy algorithm, the massive computers, or is it something else entirely?
You guessed it. It's labeled data. I mean, for an AI to learn what a cat is, it has to see thousands, maybe even millions of photos that a person has pointed to and said, yep, that's a cat. This whole process is called supervised learning. And honestly, it's the foundation of pretty much everything we call AI today. And its appetite for this data, it's practically infinite.
And right away, you can probably see the problem. This massive, insatiable appetite for data creates a huge challenge. If every single photo, every single sentence needs a human to label it, how on earth can we possibly keep up with the demand to build these ever more powerful systems?
And that really brings us to the core issue here. Manual labeling is the single biggest traffic jam in AI development. It's slow, it's super expensive, and let's be real, it's pretty tedious work. It just can't scale at the same speed as our ambitions for what AI can do.
So, to get around this massive bottleneck, researchers have come up with some incredibly clever workarounds. And the first one is all about getting more bang for your buck from the data you've already got.
It's a technique called data augmentation. You can think of it like an artist who sketches a person from a bunch of different angles just to understand them better. Well, data augmentation does the same thing for an AI, creating slightly tweaked copies of the data you have to make the training set way bigger.
And what's really cool is just how simple these tweaks can be. I mean, you can take just one labeled picture, and by automatically flipping it, rotating it, and cropping it, you've instantly created a handful of new training examples. This is great because it teaches the model to recognize the subject in all sorts of different conditions. It's a really simple trick that has a massive impact.
Okay, but what if you need to label gigantic, totally new data sets? Augmentation definitely helps, but it doesn't really solve that core problem of getting the first labels in the first place. For that, we need a way to move beyond manual work entirely.
And this is where a really interesting technique called weak supervision comes in. The big idea here is to just stop relying on perfect hand-labeled data. Instead, you use a bunch of imperfect, sometimes noisy sources. Think simple rules that a developer wrote, or even other AI models, to generate labels programmatically and at a massive scale. And this idea is becoming so important. A fascinating case study from Google on their system's Snorkel dry bell actually pointed out that as AI models themselves get more and more standardized, it's the data strategy, how you label and supervise your data, that really separates a good model from a truly great one.
And hey, the results really speak for themselves. In one test, the Snorkel dry bell system was able to identify 58% more real-time events than a simpler method that just kind of mashed all the noisy data together. By being smarter about weighing and cleaning up these weak labels, they got this huge lift in performance.
So we've got more data, and we can label it at scale. Problem solved, right? Well, not quite. In our race to get more and more data, we've kind of stumbled upon a much deeper and frankly more dangerous problem with the quality of that data.
Think about this for a second. What happens when the data we're feeding our AI is just a mirror, reflecting our own historical biases and prejudices? Getting more of that kind of data doesn't fix the problem. It just makes it bigger. It just amplifies it.
To really get our heads around this, let's look at how researchers frame the issue. They often split the data based on sensitive attributes, creating what they call a privileged group and a disadvantaged group. Now, this could be based on race, gender, or any other factor that reflects real divisions in society.
Labeled bias is what happens when those divisions actually poison the data. So imagine a data set for loan applications. If, historically, prejudice meant that a privileged group's risky application sometimes got mislabeled as safe, while a disadvantaged group's safe applications were mislabeled as risky, well, the AI is just going to learn to replicate that exact same systemic injustice.
And look, this isn't some theoretical problem. It is happening right now in some really high-stakes areas. We've seen it in recidivism prediction algorithms like Compass, in credit loan applications, and even in things like law school admissions, where this biased data can lead to models that unfairly penalize entire groups of people.
This makes one thing absolutely clear. We can't just build better models. We have to build them with better, fairer data. And that realization has sparked a whole new wave of research, focused on finding and removing bias directly from the training data itself.
One really promising approach from recent research is a kind of co-teaching.
So here's how it works. First, you train two separate models, but on data from different demographic groups. Then you have them basically check each other's homework on the full data set. When they disagree on whether a label is correct, that's a huge red flag for potential bias, and that data point gets filtered out.
But there is a really subtle catch here. If you just filter out any data point the model seems less confident about, you might end up throwing away perfectly good, fairly labeled data from those disadvantaged groups simply because there's less of it to begin with. You could actually make the fairness problem worse by accident.
So to solve this, the researchers came up with a much more robust solution. Instead of using a simple average or a mean estimator to decide what to filter, they created something called a truncation method. This new approach is way better at spotting the biased labels without accidentally throwing out the fair ones. And that leads to a much lower error rate, especially when there's a lot of bias in the data.
The researchers wrap up with a really powerful message of hope. They basically show that if we're smarter about how we choose our data, if we actively filter for the fairest examples, we can actually eliminate the influence of label bias. It is solvable.
Which leaves us with a final, really critical question. At the end of the day, the algorithms are just the students. The data is the textbook we're writing for them. So as we build the future of intelligence, we have to ask ourselves, are we sure we're teaching it the right lessons?